Next slide, please, Noel. Our speakers today will present and demonstrate the benefits of operating rail assets in an SAP digitally transformed organisation. Benefits that not only improve profitability through improved maintenance and operations, but can also improve the carbon footprint of your assets, thereby significantly supporting your organisation's green agenda. Irrespective of industry, it is more vital than ever for organisations to transform digitally. The IDC have recently predicted that by 2022, just next year, 65% of global GDP will come from digitally transformed organisations. The COVID-19 pandemic has accelerated that need for digital by some 30%. We at Rizing will show you how we accelerate our customers' digital journeys. Our panel of presenters today are amongst the asset industry's most respected professionals. We'll be joined by Satish, who leads our Benelux business and is very hands-on in guiding businesses like yours on the digital journey using SAP solutions. He'll hand off to Noel, who's the CEO of Rizing's EAM business unit, and is also one of the world's most respected industry influencers in rail intelligent asset management. And then last but not least, and gluing it all together, we welcome Connie, who has over 35 years of experience in geospatial and transportation management. Next slide, please, Noel. But before I let our speakers loose on you, a little about Rizing. Again, next slide, thank you. Founded in 2005, Rizing is an SAP specialist in consulting and implementation of SAP solutions. We're very lucky to have almost 1,300 SAP experts within our organisation, further complemented by the partners that we work with. We're also very lucky to have 4 digital development centres across the world, based in Malaysia, Bangalore, Sri Lanka and the Philippines. And those development centres are bursting full of SAP expertise that address a number of different industries and a number of different solutions. Whilst today's focus is going to be on enterprise asset management and geospatial solutions, we also have a massive footprint in human capital management and consumer industries. Next slide, please, Noel. While we're absolutely experts and recognised by SAP in being one of the best in the world at implementing standard SAP product, we're also experts in industry. We also have our own products that enhance SAP standard products for particular industries. Some of those we're going to see today. At the end of today's session, there will be an opportunity to challenge our presenters with challenging questions, and we enjoy those. And we'll cover that in a Q&A session at the end. Next slide, please, Noel. So after that quick introduction, I'd like to hand over to my colleague Satish, who will start to talk about European geospatial integration.
Thanks, Andy. So as Andy mentioned, we are global active, and we have a really big passion for when it comes to rail. Today we will not focus on the whole rail industry, we will primarily focus on the infrastructure side, of course. And in the infrastructure, mainly what we see in Europe is that there is a lot of focus currently on collaboration, integrated platforms, but also making sure that all processes to actually make sure that infrastructure stays stable, that's integrated with each other. Difficult job is actually the first answer what you always get. What we have done, what we basically are showing in this slide is that from one hand we are collecting the data, try to actually merge that into the backbone of the asset data in the systems, and make sure that we are able to define the correct maintenance strategies to keep our rail infrastructure safe and reliable, so that our trains and our passengers are can travel in a respectable way from destination A to destination B. A lot of data is involved into that. If you look at the left section, as you can see, geographical data, talking about, for example, weather information, which has a big influence on the condition of the tracks. Satellite data to basically see what the underground is of the tracks, where the tracks are basically lying, and what kind of influence that has. LiDAR data, we're going to demonstrate how LiDAR can be used to actually define your asset register, and how that can integrate between several systems. So all type of data, which is really useful to, on one hand, define your asset register, but also making sure that you can manage the asset based on the most efficient asset strategy. Talking in terms of what in Europe currently is really relevant is BIM-OTL. BIM-OTL to create transparency across all stakeholders, which are making sure that the assets on the rail tracks are reliable. And then we make a distinguish between the functional, the physical, data of the asset, but also the location data. And on top of that, topology to visualize how all these assets are linked to each other. And for that, several systems comes into play. The core system that we are focusing is an SAP and a GIS system. GIS to actually to manage the location and geospatial attributes in collaboration with functional data, and get it linked to SAP to actually plan and execute your maintenance on these asset data. All this data is tied into each other, and as you can see from a more asset management, more maintenance perspective, it goes from predictive to actually breakdown management. All this information is necessary, but it basically can, when the dots are tied to each other, it will make sure that the asset safety, the safety of infrastructure, and the reliability of infrastructure will certainly improve. So from that, I'm not gonna, I would like to hand over to Noel, who is gonna guide you through the systems together with Connie, and show you how this integration can work with respective to asset management and particularly maintenance management. To you, Noel.
Thank you, Satish. All right, so we're going to walk you through a demo that was purpose-built by Rizing to address a real-world scenario in the transport space. So this is not a technological demo for technology's sake. This is utilizing technology for a real-world scenario that just about every Class 1 freight railroad here in North America and most of the transit railroads that we've worked with around the world will certainly empathize with. In keeping with that same philosophy, we've built a purpose-built demo environment for you, not just for today's webinar, but indeed to basically crystallize an industry best practice that is both endorsed by the SAP asset management team known as the Transportation Industry Business Unit, or IBU, on the SAP side, as well as their counterparts at Esri, which are focusing on the transportation solutions inside of Esri. So the demo environment that we're going to show you, the real data that's coming from one of our clients, Norfolk Southern Railroad, is put together with the explicit endorsement of both SAP and Esri going forward as a best practice in the way not just of integrating the two systems, but in a specific type of scenario, which hopefully will resonate with those of you on the call. Really, the foundation of what we're showing you here is going to be part of a LiDAR program. Now, these LiDAR programs are certainly sporadic, but every year more and more of these programs are being utilized by the rails and the metro systems, both in transportation as well as in oil and gas, as a cheap and efficient way of surveying the network and looking for anomalies, either new or old, as well as things where objects have moved. So the scenario is going to first start with a LiDAR example, then showing how it gets laundered through the GIS system, and then ultimately how it becomes actionable on the SAP side. The scenario that we're going to show you, again, starts with LiDAR as a point cloud, and we're going to show that to you inside of ArcGIS, or actually my colleague Connie will do that. She'll walk you through how ArcGIS will be used to identify a new road crossing. This would have been new construction. Here in the US, we have positive train control. In Europe, similar systems, in fact, that predate the US network around positive train control that require a high degree of spatial accuracy in the creation of these files. So the example that we're going to walk through has a new road crossing that was constructed on a network, and we're just done the LiDAR survey for it. This is part of the overall commissioning process that we're addressing. This is where master data is created and integration between Esri and SAP is first undertaken. So we'll start off in the GIS systems. Connie will show that, and then the integration will fire between two applications in a one-way flow from GIS to SAP. I'll show you the SAP product GEF, which is the visualization engine inside of SAP. We'll then go into SAP for the hierarchy to show how that data is structured inside of a linear-based network. Then we'll push that through the work management side, which is something that I will bang the drum on during this presentation. Too often, the integration focuses just on the master data. We endeavor to show you here today how work management should also be integrated between these two systems, all the way down at the very beginning. From there, we'll execute in a mobile device. We'll execute against that commissioning work order to create transactional history and cost. And then we will end the demo where we started, back over on the Esri side, where we'll show some dashboarding that is part of Esri's kit, as well as some visualization tools that Rizing has developed that, again, are purpose-built around rail and similar transportation industry use of these technologies from a visualization as well as a actualization of the data that you see. Everybody should be able to see now my screen again, and this is the GEF part of the presentation. Andy, can you validate that for me?
Yeah, we can see that now. Thanks.
Okay, good. So what you're looking at here is an SAP tool called GEF, Geo Enablement Framework. And this is essentially SAP's visualization engine inside of a LAM and Geo-enabled HANA database. We will go in and these are the various layers. Now I'm using some Esri terminology here when I talk about business layers, but part of the configuration and part of the way that you enable visualization in your work management and asset management processes is by going through and defining, as part of this this type of a program, what are the various layers, be they work management as well as asset management, that you would like to present to the roadmasters and track inspectors and the group that interact with the asset and work management base in a purely visual manner. In this case, the example that we'll give is a grade crossing, and Connie will come back and show you later, but the road crossing that we built for this demo is 2530. We'll come in, and here is the road crossing itself. I'll zoom out a bit, and again, she will, when we go back into Esri, we'll show you, this is actual data from the Norfolk Southern Railroad that was donated for the cause, because they're both an Esri and an SAP user. This is a section of track in West Virginia. All I'm going to do is I'm going to turn on some of the asset overlays that we're showing. Now that X, of course, is the actual road crossing that was created in GIS. I'll turn on additional switches and grade crossings that are peers of it. Again, the purpose of this is not visualization for visualization's sake. If you've got a composite structure where you have multiple assets that are engaged and built into a single asset repository in SAP, you have different groups inside of the engineering and infrastructure departments that interact with each of those classes. So the point is that this is a single source of truth and a single visualization of a section of the network, which is important from a work management perspective to deconflict work activities as well as find your assets if you're unfamiliar with the territory. However, as I've been stressing, work management and asset management go hand in hand with each other. So the visualization engine that we're showing you would be really kind of crippled to some extent if you did not have the ability to come in and also overlay open work and open work requests in the form of notifications and work orders. Now, part of what we do in these implementations is we build out a pretty robust set of filters and set of pre-existing queries that would mimic work management best practices. So for instance, in this case, I just turned on notifications, and you'll see in the purple how there are sections of the track that have notifications on. These could be capital notifications. These could be OpEx type of work that we want to add in. and repair the track over time. And then, of course, you can have a linear work order that overlays the whole thing. And this could similarly be defined by work in progress. So a common example of how we use it in the United States is in the fairly large territories that the freight railroads have in the West. The weekly track inspections that they must do by high railing through the territory are rarely done in one sitting and end to end uninterrupted. So over the course of the week, the track inspector inspects sections of his track, confirming his activities against the open inspection work order. And so the visualization engine, as the week progresses, does identify where he needs to spend more time in his territory going forward. This map is interactive from a standpoint, not just of the fact that we've got layers that we can turn on and off, but any asset class that is identified on the track. You can hover over and right click on anything, and you can find, again, customizable various information about that technical object, its lat and long location, its status, as well as the IDs and things like that. So that's it for the visualization of it. Now I'm going to jump into the SAP hierarchy. For those of you that I jumped ahead here, obviously we're showing you in a Fiori, type of an example, and this is not the ugly old GUI that you may be used to on the SAP side. I'm showing this network, which is a corridor, which is the terminology here we use in the United States in Norfolk Southern, called the N62 corridor that runs through this West Virginia section. The hierarchy that we've chosen to show here is one that we have built out here in North America. That has certainly survived some best practice challenges as we've implemented across 6 freight railroads. There are equivalent examples of this that we use in passenger rail as well. The point that I'm showing you is that the corridor itself, every one of the objects you see on the left are both linear and spatialized. All right, they carry geometry inside of the SAP system. The system of record for it is the Esri application. So we consume data from Esri and map it directly through the connector, directly to the technical objects that you see. However, SAP still in its heart is a hierarchical type of a structure. So the example that you see here is we start at the corridor itself, which is basically fence line to fence line and runs all the way down through the section of West Virginia. We've then broken it up into the track level, which is, again, a geospatial friendly view of it. The shapefile data for that track is maintained in Esri, everything about it. And anything about attribution that can be maintained in Esri and brought across does come across and match over to here. Then we go into this section here called track segments. And this is the operational layer in our structure. This is where we mimic effectively the link node model that represents the dispatcher's control system. This could be in dark territory, could be switch to switch, or in train control territories, it generally is control point to control point. Regardless, what it does is it allows us to consume and interact with operational data on a one-to-one level without a gigantic translation engine. Within the track segments, I can then open up and look at the technical objects locations that are in here. So again, Mercury has fired overnight, and this is the road crossing XING 2530. This was created by the interface. Now, the interesting thing about this is it wasn't just created inside of SAP and left to float endlessly without relevance and connection. Because of the intelligence that we built into both Mercury as well as the ArcGIS tool, the ArcGIS tool not only comes into SAP and finds the next available ID, if you'll notice it's ascending numbers here based upon object type code, but it also knows, because of the linear reference and where you're putting it on the track, what its parent should be and what goes ahead and creates it. So if you think about what that means from a best practice perspective, this effectively answers once and for all whether you should be creating parallel objects in 2 systems and then connecting them forcefully after the creation. Everyone knows that while those 2 systems are creating data at different points, the connection of it never links up very well and very easy. And every time you have unconnected assets at certain levels in the structure, it does create a risk point for you from an audit and from a usability perspective. So in this case, we've taken the model as well as has Esri and SAP as a best practice and said, create the locations in Esri, have the interface engine build the objects for you from the very beginning connected to their doppelganger in the other system. And then from there, build out your work management going forward. Again, within this structure, this object here, XING02530, only represents the location of the object. It is entirely upon the SAP side, or the management system side, how you build out that structure. The only requirement is that it be a link to a parent, in this case, the location. From there, you are able to consume and propagate down through the hierarchical models any data that is managed in SAP, any data that is managed in Esri. All connect through that node and can be pushed down to objects irrespective of cost center, organizational alignment, age, anything like that. And what this does is it presents to the maintenance department individual interacting with the physical object everything that he needs, irrespective of what data source it came from, everything he needs at the point of execution for him to make an intelligent decision about what he does going forward. I'm going to switch over here to Hydrogen. Now, what Hydrogen is just like any other partner from SAP. Everybody has built out a mobile solution going forward. Hydrogen is our mobile solution here at Rizing. It's a Fiori-based, tile-based system, very much like Asset Manager. And we've taken the time to, in this demo, to show you one more level of integration, which we find very important. Too often when we are engaging with clients for the first time, one of their pain points is that their data people are disconnected from their work management people. We all know that data doesn't change spontaneously, nor through the hand of God. It takes the hard work and diligence of the maintenance department to make those master data changes. And so we thought, when we were building this model, why not take that right to the root of generation? And that is to say that this road crossing must be commissioned, and the event of commissioning it should not be disconnected from the act of creation on the technical object. So effectively, in half as many words, I will say this. What the Mercury engine will also do is it, in this case, will create a notification, right, which is the beginning of the work management event. It will create a notification at the same time that it creates the technical object node for you to interact with. And this notification here now becomes the connector between the act of doing, which is the commissioning event, and the act of data creation, which is the technical object event. We can build out in standard SAP format as much detail as is needed. There could be a task list connected to this for the commissioning steps. The point of what I'm going to be talking about here is that we prefer to create it as a notification because there may be a whole bunch of other work activities being done as a combined work order. In this section, the commissioning of the road crossing may simply be one of many things that you're doing at the same time. So in this case, I'm just going to go ahead and create the work order from this notification. I'll go with a T01 inspection work order, and I will go ahead and save. Let's see, control key, PMO, it's all good. So what this is doing is it's promoting the notification to a work order. Very standard for those of you on the call that have used SAP in the past. This is unchanged from that perspective. Just waiting for it to finish connecting here. All right, so I've gone ahead and I've come back out. I'll now click onto the work order side. And I will search for that road crossing. Again, I don't need to find things only through list edits and things like that. I can also find objects through their technical object ID going forward. So here's my work order itself. I'm going to go ahead and release it. Which is now released. And I'm going to do a very, very large time confirmation against it. Just so that it shows up in the dashboard itself. So just make it gargantuan. We'll put 100 hours in to inspect this particularly problematic crossing. Again, the connector between the two applications moves work management as well as master data management. So while I'm filibustering here for a moment, the connector is firing in the background. It is taking this fairly large time confirmation, and it's going to be sending it back to Esri system as a layer that can be visualized just like we started in the GEF side, showing work in progress as orders and notifications. Similarly, you can do the same thing on the ArcGIS side.
How we normally start this demo is showing the addition of the rail crossing. And this isn't how you would normally add an asset to a GIS database. There are a number of different ways that we normally do that. We can use Esri's or field data collection tools called field maps. We also can use LiDAR. So what you're looking at here is a scene in ArcGIS. And this is LiDAR data that we collected for Norfolk Southern. As Noel probably pointed out, we've been using Norfolk Southern data. This is a corridor that we collected that's about 150 kilometers. It goes through a very mountainous area, so there's 17 tunnels. And we collected the LiDAR data as well as imagery that you're going to see at the end of the demo, and we extracted features. And so you're going to see some of those features that we extracted as we get into the rest of the demo. But for this part of the workflow, we just added this rail crossing that you that Noel's been talking about. And as soon as I added that in the GIS layer, it fires Mercury in the background, and it created this crossing, the flock ID, again, that Noel's been working with. So if we had been doing this demo the way that we normally do it, we would have created that first, Mercury would have fired, and then Noel would have taken over and shown all the things that he just went through. So now that Noel has created the work order and the notification, we normally come into this part of the demo, and this is the Esri Operations Dashboard. This is a really great tool for configuring your data and visualizing it, summarizing it. What we've created here is completely configurable, but we've got a list of the work orders over here on the left. And then you've got a count of the work orders here. So it tells you that along this section of the rail that we've got 123 work orders. We've also got a couple of pie charts here. This one is showing the work orders based on the priority that they are in. We've also got another one here that shows the work orders based on the phase that they are in. And if you click on any of the wedges here, it filters down and just shows you the work orders. And you can also see this bar chart over here is updating as well, showing you the amount of cost that's been put in for each one of these different types of work orders. So if we go back to the whole screen, you'll see that you've got all your different work order types up here. And then this rail crossing that we've been working with here has now been added, or the work order. So this is what Noel just added. So as soon as he added it to SAP, it is added back to the GIS environment and is available here in this work order dashboard, as well as in the Rizing product called Rail Analyzer. And I've already launched that. And so this is our straight line diagramming tool. This allows you to look at both linear and point features. For the most part, we show all the point features up here in the top part of the diagram. So you can see we've got crossings. We also show all these work orders. We've got signals and switches and anything else that is in your database that you can visualize up here. So we've got bridges. If you hover over any of these, it gives you some basic information, this is again configurable about the particular asset that you're looking at. You can click on them and it will give you everything in the database about the asset that you're looking at. And you can also hit this feature grid and it shows you, so I clicked on the bridge, so it's showing me all the bridges that are along this particular section of the rail. At the bottom of the screen is where we have all of our linear attributes. And so this is data that we got from Norfolk Southern. It is their real data, for the most part. I think actually all of this is their data. And so you can see here, we've got information like when the rail was actually laid, the type of rail, the maximum speed, the curvature, control. We have some clients that may have several hundred of these linear attributes or linear assets. And And so trying to show those in a map view gets very cluttered. And so we think this is a great way to look at a lot of information about a smaller section of rail or road. We also use this as our integration tool. So, and you can see we can move up and down the rail. If you had lots of mileage or kilometers here, you could just keep stepping through those. But we're going to turn on ArcGIS map. And this is where you start running out of real estate for a demo. You can pop any of these windows out to another screen. So if you have multiple monitors, you might have your map up on one monitor, your SLD up on another monitor. You could even have a third monitor. We're going to show you here the video log in a minute. But as we move along this section, so the red dot shows where we started this section, and the green is the end of that, and then the yellow is where this gray bar is, so it shows you your current location. And as I move along here, you can see that the yellow dot is moving in my map. So you can kind of get the best of both worlds there, allowing you to look at, again, both your SLD as well as your map. And then the last thing that we typically show is the road video viewer. So as I mentioned at the beginning of not really the beginning of the demo, but as I mentioned earlier in my part, we collected LiDAR data as well as imagery. And we have a Leica Pegasus 2 system. So we collected survey grade LiDAR data as well as, like I say, this imagery. It's 360-degree imagery. You can hook up imagery that comes from a mobile mapping system, or if you've got other video log data, you can add that and integrate that in, and you can see here, as hopefully you can see that on your screens as well as you're moving along the video log, you're also moving along your SLD. And with that, Noel, I will turn it back over to you. Are you guys still there?
Yep. Thanks, Connie.
I apologize for the technical difficulties this morning.
I'll share my screen real quick.
Yeah, Connie, no apologies necessary. It was a mean technical feat we tried to pull off today. And if anybody would like to see the demonstration in the right order, then maybe watch the recording backwards, and it might make a bit more sense. I think we've now got an opportunity for questions and answers, or hopefully answers to go with questions.
One last thing I'd like to add here before we go into the Q&A, Andy. Again, we showed you a fairly defined script that we built out in coordination with Esri and with SAP. However, very few parts of it are fixed in which application you do this work in. One of the things that we could show in a parallel or a secondary demo for folks is that there is an equivalent view of this where you're actually showing almost all the visualization inside of Esri products. It really comes down to what the defined server stack and software packages look like at the client side, where they're strong or where they're weak. This is designed to be ultimately very flexible, but the visualization engines that Esri have are every bit, if not exceeding, most of what SAP can show you in those areas. The reason why SAP has the GEF tool at all is in a scenario where they've got end users that are restricted inside of just the SAP side. But the real value here, I think, with the visualization is on the Esri side of things. They can do so much more with the functionality of the layering and the consumption of data and the transposition of that data into technical objects going forward. So if anybody on the call needs to or wants to see that, we have an equivalent demo that stresses more on the Esri side of things. So that's just something I like to put out there, because again, it's multiple ways of showing these two systems. But the key takeaway from an integration perspective is that just about all of asset management for a railroad, a highway department, and increasingly the transmission and distribution side of utilities ought to start on the Esri side of the equation. It first starts either as a capital project or a concept that is first communicated and built out and modeled in Esri tool sets. From there, you then build out the nameplate data information on the SAP side, and then you obviously connect the two as construction begins and as commissioning and operations go forward. So that's my one last thing I wanted to add based on the complexity of this, but I'll now open it up to questions.
So, Nicholas, have we had any questions that the panel can answer today?
We do, and thank you so much for that great presentation, guys. The first one here is actually, there was a brief mention of Mercury. The attendee is kind of curious, just if you could describe Mercury a bit more.
Sure, I'll take a start with that, Nick. So as we said, Mercury is a product. It's a product designed by Rizing. It is obviously approved from the SAP side of things as an app in the App Store at SAP. What it is an integration engine, a fairly flexible integration engine that handles both work management and asset management. It is bidirectional in its nature, but it is not completely unstructured in that, as part of our best practices, when we discussed this with both Esri and with SAP, this is how we ended up with that origin point in Esri, and then the circle back through SAP and back in. So while it is bidirectional, we try to force the application to follow endorsed business models and business processes, where you are creating data for the first time in the correct system, and then that data, as well as additional geospatially linked data or technical object linked data, is first connected to the equivalent record in the two applications, and then passed as needed for reporting and or business actualization into the two. So from a standpoint of implementation, it can generally be installed in a dev, test, and a production environment in a few days. The remainder of whatever project there is generally is around data cleanup, as well as building out layers in Esri, the equivalent of them in SAP, as well as defining the data model that the application should synchronize, which type of objects, which attribution, and then from a work management perspective, back over to the GIS side, which order types, which statuses are you building? And I'll stress one last time, this is not technology for technology's sake. We put a lot of pains into when we build these things to have the technology support a aspirational business practice that you're moving towards, not necessarily data overload connecting these two systems. There is data that should clearly be the purview of one application or the other. And then there is data that should be shared, and shared in the point of visualization, which is, again, I think a really strong point of the GIS systems and the Esri products in particular, is around that visualization piece of it, so that you can have the maintenance departments bring that parameter into their decision-making process. And then lastly, well, we showed you a bit of the reporting side in the dashboards and stuff like that. There is an entire other world of geospatial reporting that is being spearheaded by Esri. If you look at it from a standpoint of what, from a persistency of master data and a persistency of history, the only real persistent data is geodata. Objects come and go. Their purposes are ephemeral. Their lengths, their locations on the ground, even their depth in the case of the pipeline world, they come and go. But there is one aspect that is immutable, and that is history that's tied with a geotag to it. And that's the direction that we've seen the industries move, and we as a firm have moved to build the Mercury product to support that future reporting aspect as it becomes more and more mature. But I can conceive of a day in the not too distant future where just about all of your asset management reporting from a historical perspective that would feed into capital decisions and feed into regulatory reporting may first come out of a Esri generated report, because that's the data set that is the most rigid from a standpoint of history, and probably the most defensible.
Great answer. And did I hear correctly that Mercury's further information on Mercury is available in the SAP App Store?
It's absolutely for sale in the App Store, and then obviously anybody on this call that introduced themselves at the beginning can wax philosophical on said subject as well as increasingly through the geo practice here at Rizing can speak fairly intelligently about Esri as a product, and some of the tools that we've built on the Esri side, as well as the Esri delivered applications as well.
Brilliant.
I mean, Connie, if you want to talk a bit about roads and highways, That's something we should probably also highlight here today. And linear reference.
Yeah, I can certainly talk about roads and highways. We've done a number of those implementations here in the U.S. In fact, we just finished one of the implementation of one of the newer versions, or the new version of Roads and Highways, the Roads and Highways Pro version. And you know, what that allows us to do is to tie all of this linear reference data to the network. And as your network changes, it keeps all your business data in sync. And it also allows you to do all the temporal analysis. So you can look at, what did my network and associated data look like 6 months ago? What does it look like today? And start doing comparisons and some really high-end analysis. So that's a product that here in the United States has been widely adopted by the Departments of Transportation. I think of the 52, if you include Puerto Rico and DC, I think 40 something of them have implemented, and most of them are in production now. So it was a tool that a lot of the transportation agencies here in the US were just dying for, and has been really successful over here in building a foundation for them to put all their other applications on top of, because really after you get your LRS in place, then it allows you to share data across your agency, you know, with all of your different operational systems.
And I'm glad you mentioned LRS, Connie, is to further that point. If there is an area that SAP is very, very dependent upon, the geospatial systems and Esri in particular, it's around the LRS systems. Often when we're doing discovery calls with clients that are looking to further enable these two applications, what befuddles them on the SAP side is the linear referencing and the dynamic segmentation piece of it. The LAM, or linear asset management functionality, that SAP has rolled out about 8 years ago in Enhancement Pack 5, that does the very basics in that it provides a home for a lot of this data, but the manipulation of it and the management and maintenance of it going forward is very, very difficult in a purely SAP system. So as Connie mentioned, Roads and Highways is a very good tool set that Esri has that manages the LRS system, and certainly relieves a lot of kludgy development work on the SAP side to even make a go of it. So from a standpoint of how the two systems interact, managing dynamic segmentation and linear referencing, SAP is very, very, if not entirely, dependent on the integration of the two systems to manage that data set going forward.
Super, thank you. Comprehensive answers there. Nicholas, any further questions?
Yeah, we have one more here. Someone's asking if they can get personal access to a demo version or a way to access the things we see today.
Well, all right, I'll take that one as well. So as I discussed, this environment that we've demoed here today, that was built in coordination with both Esri and SAP. We're hosting it, but we have always taken that it's in a bit of an open city. Now, quality of data is important, so it's not a wide open free for all. Here's a link, go and start creating, road crossings in the middle of mountains and stuff like that. But from a standpoint of getting a further dive into it, and maybe even having us or Esri or SAP upload some of your master data to see it in a purely personal format, this environment would certainly be a good candidate to do that, because it's got all of the connectors already built out, and existing models where loading the data is fairly quick. So anybody on this call from a Rizing perspective, but if you feel more comfortable going through Esri or through SAP, all of them eventually will have access to this demo environment, and can walk you through, either in collaboration with us or with each other, walk you through an example of this again, and spend more time on the technical bits and bobs and things like that. But the environment is an open city from that perspective. All three service companies have access to it and can run you through this one more time, or with a slight nuance.
Awesome, thank you, Noel. Any final questions, Nicholas? I'm conscious of time.
I believe that was it. So thank you so much for those questions, guys. We really appreciate it.
Okay, well, I'd like to thank today's panelists, and technical glitches aside, I think there was some very nifty footwork akin to England versus Germany last night in the European Championship. So Noel and Connie, thank you for thinking very quickly on your feet. So I'll bid a good afternoon to my European colleagues, and I hope my North American colleagues. Have a good day, and thank you everybody for joining, and hopefully you'll join us again for another webinar in the next few weeks.
Thank you.